Okay, today we've looked at parts of similar triangles. Previously we looked at proving triangles similar. We looked at corresponding sides of similar triangles, how they were proportional, and how to find missing sides. Today we're looking at three specific special segments and how they are proportional to each other and to the sides of similar triangles. You can probably tell by the diagrams on your notes what those three are. They are altitudes, medians, and angle bisectors. Okay? And what this means is, let's look at these altitudes first. With these altitudes, I have segment AB and FG. If these are similar, then those two segments are proportional. So AB over FG, that ratio is going to be equal to the ratio of the altitudes, which in this case would be AD over FJ. Same thing for medians. If I'm looking at, say, this side, I would say AC over WY. That ratio is going to be equal to CD over YZ. Okay? And then here we have, we'll say RS and LM. That ratio is going to be equal to RT over LP. Let's look at an example of that. So here we have two triangles, and we have angle bisectors. Let's do this. We're going to solve for x. So this angle bisector is going to be proportional to this angle bisector. So I'm going to have x over 8, and that ratio is going to be equal to this side of the triangle over this side of the similar triangle, which is 12. Cross multiply and you get 12x equals 120. 8 times 15 is 120. 12 times x is 12x. We'll divide both sides by 12. And x equals 10. That's the length of this segment right there. Okay, so that's how we, not different at all. The only thing different there is the fact that we use an angle bisector in the ratio because now we know that they are proportional. All right, now this last part says, this next part, which is the last part of our notes section, an angle bisector in a triangle separates the opposite sides into two segments that are proportional to the lengths of the two other sides. What this is saying, what we've done before is we've used two similar triangles. This is one triangle. Now what's happened now is we have drawn an angle bisector, and we're saying that the two segments, one segment there, two segments there, the two segments that it divides into half are going to be proportional to the other two sides of the triangle. So we're going to say KM over LM. We're talking about these two segments, this one and this one. They're going to be proportional to KJ over JL. That's what the triangle angle bisector theorem states. So let's look at that in our example down below. We're going to find x here. So here we have an angle bisector. That means these two segments are going to be proportional. So that ratio right there that we're looking at would be x over, since we have this side, we're going to put this side over this side, but we don't know this length right here. We know the whole thing is 18, so we're going to take 18 and subtract x from it. And that's going to be the other side. Now that's going to all be proportional to this side, which was 6, over this side, which is 14. Now I cross multiply, solve for x. We get 14x equals 6 times 18 minus x, which if we do the work there, we end up with 108 minus 6x. Add 6x to both sides, and we get 20x equals 108. Divide by 20, and x, which is what we're looking for, equals 5.4. So that's an example of how to find a missing length of a triangle when we have the angle bisector. All right, you shouldn't have a problem on the assignment looking at those problems. There are some word problems, though, that I do want to go over and look at. So this problem's on our assignment. Here we have someone standing up with a shadow. Now, these two triangles are similar to each other. We know that because these two angles are congruent, which they're both right triangles, so that means they're similar because of angle-angle similarity. So then the sides are proportional. So if we convert this, and that should be a 5 feet 3 inches, if we're converting that to inches, we would have 63 inches. And if we were converting 4 feet 8, and actually I think it's 4 feet 6 inches, we would convert that to 54 inches. And 8 feet 3 inches would be 99 inches. So we want to know how tall the statue is, which is this x value. So it's kind of neat that we can actually look at this stuff and figure it out, figure out the height of something without actually knowing, getting up there and measuring it. So then we just make a proportion problem. 63 over x, those are corresponding sides, equals 54 over 99. And when we solve that, we end up with 54x. Set that equal to 99 times 63, which I didn't do that on my paper, so I'm going to figure that out right now. 99 times 63, you get 6,237. We'll divide that by 54. And this will give us our height in inches. If we wanted to convert that to feet, we would divide it by 12, which would give us, that would be inches, 9.6 feet. Basically, a little over 9.5 feet tall. Okay? All right, look at this. Number 2, we have an artist makes a scale drawing. So it says a drawing of what they're planning to have a lion enclosure at the zoo for. The scale is 1 to 25. 1 is the inches, 25 is the feet. So on the drawing, the length of the enclosure is 7 1/4 inches. Remember, drawing is on top, the actual length is on bottom. So we're going to put 7 1/4, which we're going to write as a decimal, 7.25. We want to know how many actual feet that enclosure is going to be. So we put it there. Now we just cross multiply. X equals, and we end up with 181.25. And we're talking about feet. Okay. 3 is a very similar problem. A visual effects maker for a movie draws a spaceship with a ratio of 1 to 24. That's our ratio. The drawing of the spaceship is 22. So remember my ratio. 1 is every inch on the, or whatever unit, they don't tell us the units, but whatever that is, it's going to actually be 24 actual physical feet. So if the drawing is 22 inches, what's the actual length in feet? That we don't know. Well, we cross multiply. We end up with x equals 528 when we do that. Okay? The next one we're looking at, we have kind of the floor plan or setup of a kitchen. Notice the scale right here is 1 centimeter to 2 feet, so 1/2. The width of the kitchen. If you would take a ruler and measure it, you would find that the width is going to be 3.5 inches. Now, the 1 centimeter is the drawing, the 2 feet is the actual measurement, physical measurement of the actual kitchen. So if my drawing is 3.5, and I want to know what the actual measurement is, that's what how I would write that. Cross multiply, and you end up with x equals 7. That means the width of the kitchen is actually 7 feet. The length of the kitchen, if I measured this, I would get 5 inches. So we're going to use our same ratio. 1/2 equals, my inches on the drawing are 5 inches. The actual feet I don't know. I'm going to cross multiply. I'm going to get x equals 10. That means the kitchen actually is 10 feet long. Now the sink. The width of the sink is 1 inch. If I want to know what the actual width is, I'm going to use my ratio, which they gave me, of 1/2. And if my drawing is 1 inch, what's my actual measurement of that? Well, when I cross multiply, I get x equals 2. That means the width of the sink is 2 feet. Now they want me to find the area of the pantry. The area of the pantry is right here. To find area, I have to know the length and the width of the pantry. So what I'm going to do is I'm going to measure it with a ruler, and to do that I get 1.5 length, and the width is actually 1 inch. So I have to convert these to feet, so then I can multiply them in feet and find the area of the pantry. I'm going to slide this over a little bit. Okay, so I'm going to use my ratio of 1/2. I'm going to find the length first, so 1.5 over x. X equals 3. So that means it's actually 3 feet here. And then I'm going to take 1/2, set it equal to my width, and my drawing is 1 inch, which we said right here. Set that over my x, which we did this before, we get 2. So this pantry is 3 by 2 actual feet. Sorry about that, I wrote a 3. So how do I find area? I multiply. 3 times 2, which is 6, and we're talking about square feet. The back page, looking at this, I've got 2 similar rectangles. We're needing to find a couple things, the perimeter of the larger one and then the area of the larger one. Well, the smaller triangle, looking at that one first, I see that it's got a width of 10 millimeters. Now it's got a perimeter of 28. I know that's hard to read, but that's what it says. Which means this is 10, this is 20. The two ends have to have lengths of 8 inches combined, and they're congruent. so they have to be 4. The larger triangle, 15, 15, we're talking about millimeters, so now we can write a ratio to solve for that length, that height right there. So I'm going to say 10 to 15, because those are corresponding parts of similar rectangles, and that's going to set that equal to 4 over x. Cross multiply, and we get 10x equals 60. Divide by 10, x equals 6. That means these lengths are 6. Now we can find the perimeter. 15 plus 15 is 30, plus 6 plus 6, we get 42 millimeters. Now we can find the area just by multiplying 6 times 15, which we get 90. And since we're talking about area, square millimeters. Alright, and the last problem in this word problem section says, free fall ride amusement park casts a shadow at the same time. So what a person is standing casts a shadow. So what we've got is a ride casting a shadow that's bigger, obviously, than the person is. Similar to number 1 in this assignment. So the shadow of the amusement park, we're going to say, is 43.6. Just round it to that. At the same time, a 6-foot tall person, the smaller triangle, casts a shadow 2 feet long. We want to know the height of the ride. So we're going to write the ratios. X over 6, because those are corresponding parts, over, or equals, 43.6 over 2. Cross multiply, solve for x. We get 2x equals, what would that be, roughly 87.2. Divide by 2, and you get roughly, let's see, I did something wrong here, didn't I? Yeah, that's not 87.2. 6 times 43.6 is 261.6. All right, divide that, 261.6 by 2, and you get roughly 130.8, which is going to be J. Okay, you shouldn't have a problem with the other part of the assignment. I just wanted to kind of work through the word problems with you so you could kind of see how that goes. All right, that's it.